prototype of using OpenAI's new assistants to create a chatbot for scientific protocols and SOPs. So to do this, I'm going to go to OpenAI. I have the $20 a month account, so I get access to the API and Playground. Over here on the left, you're going to see assistants. This is OpenAI's newly released version of agents, right? So agents have access to tools. Agents can think, reason, do some things in the background. So we're going to create one. We're going to call it SOP Helper. We're going to give it system instructions. Now this is very important because it tells the model what you want it to do and what you want it not to do. So we may have to play around with prompt engineering to get it just right. But in this case, what I'm going to say is you help scientists with lab protocols. And here's an important bit. The GPT LLM has been trained on so many documents that it probably has some knowledge about lab protocols, but it's not necessarily relevant to your particular lab's protocol. So we're going to say you only use information from documents uploaded to you. Okay, we'll see if that works. We're going to select a model, the latest GPT-4, and we're going to select the retrieval tool. This tells the assistant to make itself a RAG tool, or retrieval augmented generation. And then we're going to select some files. So I downloaded a few protocols from just a university website. See, we have a few in here for Western blotting and a cDNA one. So we're going to upload those there. And by the way, this isn't exactly the interface that the scientists would see. This is just the playground, but it's nice because it gives you a GUI, a visual representation of the chatbot. So it's saving the assistant. Now we can test it out. Okay, so we see down here, there are the files, but I don't know that it actually loaded them yet. And by loading it, it does a couple of things. It does upload the PDFs to its local storage, but then it chunks them up and splits the text into things called vector embeddings, which is their numerical representations of the text, and then it stores it in a back-end vector database, and then this is how you chat with it through natural language. So I could say, list all protocols. And let's see. So this might take a minute because I think it's chunking the data in the background here. And we see down here, this is spinning and spinning and spinning. So this, it streams information back to me, so it's not computing everything in the background and I don't have to wait for everything. So we should see it start to output some data soon. There we go. All right, so the protocols detailed in the uploaded documents are SOP 7.2, Western blotting for BRCA1, looks good. 7.3, it's another Western blotting for BRCA1, but this is a before antibody, that's correct. And then 7.4, and then the cDNA right here, 7.1, so that's cool. So from here I could say, what's the procedure for cDNA? Now what it should do is just return information from this document alone. So it's doing stuff in the background. Hopefully it'll come back soon. I don't know if what we're seeing is delay by the model or the playground itself, but we could figure out speed moving forward. Oh, but there it is, it's back. So what's the procedure for cDNA? So SOP Helper, the procedure for synthesizing from the SOP 7.1, that's the correct SOP, and then we have all of these points. Now, in order to make sure that it's not hallucinating, I have the document up somewhere else. Let me just open it. Here's the cDNA PDF, and let's see, the procedure starts with keep on ice. So what I'll do is I'll move that to the side. I'll move this to the side and see if we can compare it. What's the procedure? Keep samples on ice. Good. First strand cDNA synthesis, total volume 50 microliters. Good. Combine the following. In a tube. Good. So let's just spot check. Mix and vortex gently. We see that too. We see the next step is heating the tube to 70 degrees Celsius for 10 minutes. That's correct. Let's scroll down a little bit towards the end. 6 is incubate 42 degrees C for 60 minutes. Good. Okay, so this looks pretty good. We probably want to go through with a fine-tooth comb to make sure that there's no hallucination there. But at this point, it seems like a pretty good start for at least proof of concept.